This is section 7.1, negative and zero exponents. Today we're going to review the properties for zero and negative exponents. As you remember from before, if you take a number to the zero power, it's 1. So you see the examples, 4 to the 0 power is 1, negative 3 to the 0 power is 1, and 5 and 14/100ths to the 0 power is 1. Any number that is not 0, if you raise it to the 0 power, you will get 1. And we noticed that when we took a look at some patterns the other day. The other exponent property that we had recently talked about was the negative exponent property. And that says if you take a base and you raise it to a negative exponent, you can change that negative exponent to be positive by writing it as the reciprocal. So if you look at the example 7 to the negative third power, if you wrote that as a fraction over 1, you would then use the reciprocal, taking that 7 to the negative third power and putting it into the denominator, and that's going to change the exponent to be positive. All right, let's take a look at an example here. See how much you remember. Our first example is 9 to the negative second power. So if we want to change this and rewrite it so that the negative second power is positive, we're going to use the definition of the negative exponent, or the negative exponent rule. It's going to go right down into the denominator, and the exponent, 2, will change to be positive. We then could take a look at 9 to the second power and simplify it to 1/81st. Let's look at another example. So here we have negative 3.6 to the 0 power, and remember we said that anytime we ever take a number to the 0 power, we always get 1. All right, let's see how much you know. What I'd like you to do here is pause the video and see if you can work through examples A through E on your note sheet. All right, let's take a look and see how you did. For the first example there, you have 4 to the negative third power. If we want to rewrite this so the negative third power is positive, we would write 1 over 4 to the positive third power. So we're really just taking that 4 to the negative third power. If we wrote it as a fraction over 1, we're then using the reciprocal, flipping that around. So if we were to evaluate this, 1 over 4 to the third power really could be evaluated to 1/64. The second one, you're taking a number and raising it to a 0 power, and any time that you do that, you get 1. Example C, 3 to the negative second power can be rewritten so that it's a positive exponent, 1 over 3 squared, which is also 1/9. Example D, 6 to the negative first power, negative exponent, we want to make that positive. We're going to move it to the denominator, so we'd have 1 over 6 to the first power, which is just 1/6. And then example E, you have negative fourth to the negative second power. So if I want to change that to have a positive exponent, I'd write it as a fraction in the denominator. Notice that the negative 4 is the base, and the base does not change. The base does not become positive. The negative 4 stays negative. The only thing that changes to positive is the exponent. So now if I simplify this, a 1 over negative 4 squared, negative 4 times negative 4, I would have 1/16. All right, let's try and challenge you just a little bit here with problem number 2. So we're going to look at this expression. It says 5 multiplied by a to the third power multiplied by b to the negative second power. We want to simplify this, noticing that the b has a negative exponent that needs to be a positive exponent. So let's see if we can simplify it. Using the definition of the negative exponent, or the negative exponent rule, we can look at that b to the negative second power and say, well, let's write it as a fraction, putting b to the second power down in the denominator. Now, if I write the first number, 5 times a to the third power, as a fraction over 1, I now can multiply those two fractions together, which would give me 5 times a to the third power times 1 would be 5 times a to the third power. And if I look at the denominators, 1 times b squared is just b squared, and so there I have it. It's simplified. I just needed to take that negative exponent and make it positive, and I can do that by moving it down in the denominator or moving it downstairs. Let's look at another one here. That x, you notice, is to the negative fifth power. You also notice that it's in the denominator. You see, if you take a look at this problem, it's reading 1 divided by x to the negative fifth power. So let's write it as a division problem, but we're going to use a division symbol instead. So now take a look at the x to the negative fifth power. We need to change that or rewrite it so that it has a positive exponent. So I'm just going to rewrite that, 1 over x to the positive fifth power, and I wrote the first number as a fraction. Now I can rewrite a division problem as a multiplication problem if I change the divide to multiply and I flip that second number. So I'm just going to take that 1 over x to the fifth power and I'm going to use the reciprocal, flip it around, and now I've created a multiplication problem. So now if I multiply, I'll have 1 times x to the fifth power over 1, which really is just x to the fifth power. Now notice what happened here. We started with 1 over x to the negative fifth power, and we ended up with x to the positive fifth power over 1. Notice it's just the reciprocal. Look again at the example. The x to the negative fifth power, that's in the denominator. To make it positive, I'm going to move it up into the numerator, or I'm going to move it upstairs, and then the exponent will be positive. I'd like you to try a few on your own. So go ahead and work through examples A through E, pause the video, and when you're ready, you can come back and check your answers. All right, let's take a look at our answers. Let's see how you did. So that first one, x to the negative ninth power. We're going to write it as 1 over x to the positive ninth by moving it downstairs. Example B, negative third power. It's downstairs already. Let's move it upstairs. We're going to change this by writing it in its reciprocal form, and the end of the third power is positive. Example C, you notice the 4, it says 4 times c to the negative third times b. They're all stuck together, it means multiply. The 4 and the b are both positive exponents, 4 to the first and b to the first. But the c to the negative third, that one's negative, so we're going to have to move that one downstairs. So c to the negative third is just going to go downstairs and become c to the positive third. Example D. 2 is perfect where it is. It's got a positive exponent, but the a to the negative third, we're going to have to move that upstairs, and then it can become positive. Well, 2 times a to the third power over 1 is just 2 times a to the third power. The last one, do you notice that the n to the negative fifth power is negative exponent? Or we're just going to move that one downstairs and make it positive. Now, notice in the numerator, it says n to the negative fifth power. I could say that it really says 1 times n to the negative fifth power. So when I move that n to the negative fifth power downstairs, there's still going to be a 1 that's left in the numerator. And this is what it would look like if it were simplified. All right. Lastly, let's take a look at a third example of the type of expression that you could see where you might need to simplify. And this is if we were to take an expression like the one shown here, and we're going to evaluate it by substituting a couple values in for the s and the t. So where are we going to start? One possibility is to simplify the expression. You notice that the t has a negative power, so we're going to move that downstairs. So you notice here that in the numerator we have 3 times s to the third power, and in the denominator now we have t to the second power. So next step here is I'm going to see that s is the same as 2, so wherever I see an s I'm going to replace it with a 2, and t is the same as negative 3, so wherever I see a t I'm going to replace it with a negative 3. So now you look at the expression and say, okay, in the numerator I have 3 times 2 to the third power, and the denominator I have t, which was the whole negative 3, in parentheses, t, raised to the second power. Now I have to think of order of operations in the numerator up there. I have 2 to the third power, 2 times 2 times 2, that's 8, times 3. And in the denominator, I have negative 3 to the second power, which is negative 3 times negative 3. So you see in the numerator up there, I have 8 times 3, which is 24. The denominator is 9. You can leave it 24 ninths, or you can rewrite it as a mixed number. So now I'd like you again to try A through D in your notes, and pause the video and then check it when you are ready. All right, let's take a look and see how you did. So that first example, we see that n is to the negative fourth power, and so I'm going to rewrite that and put that downstairs. I also see w to the 0 power. I know that anything to the 0 power is going to be 1, and that's in the numerator, and that's perfectly fine. So I'm rewriting this n to the fourth power downstairs. I can replace the w to the 0 power with a 1. That's 5 to the 0 power if I replace the w with a 5 there. And then downstairs I have n to the fourth power, the entire n. The n is negative 2, so I'm taking negative 2 times negative 2 times negative 2 times negative 2, which is 1/16. On that second example, B, notice the n to the negative first power is negative. I'm going to move it downstairs so it looks like this now. I'm going to have to substitute in a 5 for the w and a negative 2 for the n. And then if I look at the denominator there, I have 5 to the second power, which is 25, and negative 2 to the first power, which is negative 2, and 25 times negative 2 is negative 50. Third example. Numerator, I have n to the 0 power, and that's going to be just 1. And the denominator, I have w to the 6th power, which is 5 to the 6th power, and you could evaluate this if you had a calculator today. It'd be 1 over 15,625. Last example, denominator, n times w to the negative 1st power. The n is fine where it is because it has a positive exponent and n to the 1st power. But it's being multiplied by w to the negative 1st. So I'm going to have to move that w to the negative 1st up into the numerator. We'll move it upstairs and it becomes positive. Now I can replace the w with a 5. 5 to the 1st power is just 5. And n in the denominator is just negative 2. And so there's my answer. You could change it to a mixed number if you'd like, or just leave it improper. I'm going to ask you now to turn to page 417 and 418 in your book. There are 3 sections of problems I'd like you to take a look at. You're going to be picking 5 out of the first section and 10 and 4 and so on. Good luck. Hope you've enjoyed my video.